All right, today we're discussing compound events with probability. So the first thing just to touch on is a union versus an intersection, because we have two different types. So basically a union is when you have basically two circles like a Venn diagram. And let's say this is everything in event A, everything in event B. When you have every answer from A and B counting, that's basically what happens when we have an OR problem. So there's a lot of answers versus an intersection. So take your same two events, A and B, but the intersection is going to have far less because it's only what they share in common, and we refer to this as the AND. So the union will have lots of answers, the intersection will have very few. So we're going to learn a new formula right now. This formula is what you're going to use for a lot of the problems for today's notes and for Wednesdays. So if two events, A and B, the probability of A or B is equal to, I'm going to write that out again, sorry. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this A and B here on the second one is if there's some overlapping here. It'll make more sense once we do a problem. So the first example says you roll a six-sided die, so just a standard die. What's the probability of rolling a multiple of 3 or a multiple of 5? So first what you want to do is think about on a die, how many multiples of 3? Well, that would be 3 and 6. So a multiple of 3 would be like 3 and 6. A multiple of 5 on a die, it only goes from 1 to 6, so just a 5. So with our new formula, the way it will work is you would write probability. So we're going to do P. Oh, pen issues. That's my favorite pen. P, and we're going to do multiple of 3 or multiple of 5 is equal to, so this P should match here. So then we're going to do probability of A, which in this case is multiple of 3. So probability of a multiple of 3 plus, and then the B event is multiple of 5, probability of multiple of 5, minus the probability of having a multiple of 3 and a multiple of 5. So this last step won't be used all the time because you can see 3, 6, and 5, they don't share any common numbers. So we will have a 0 represent this relationship here. So you actually won't always use it, and that's fine. So if we plug in our numbers, so multiple of 3 was 2 out of 6. A multiple of a 5 is a 1 out of 6. And then like we said, for the AND, we have nothing. And then you just go through. So 3, 6, so we know that's a 1/2. So let's try one where the AND does have something. So we're going to stick with our multiples. So we're still doing multiple of 3. So multiple of 3 we know is still 3 and 6. This time we're going to focus on multiples of 2. So 2, 4, and 6, since we're talking about a die. So to set up the equation, it's probability multiple 3 or multiple 2 is going to be the probability of getting a multiple of 3 plus the probability of getting a multiple of 2 minus the probability that you get a multiple of 3 and a multiple of 2. So multiple of 3 we know is just going to be 2 over 6 plus multiple of 2 is 1, 2, 3 numbers, so 3 over 6, minus, now we want to take out the common that they share. They both share this 6 right here. That's one number they share, so we need to take it out so we're not double counting it. So take out that one number, and then you just go from there. So that'll give us a 4/6, which is 2/3. Let's try another one similar to that. So number 3 is a confusing example, so please read it just really, really carefully. I'm going to highlight some stuff because it is a little overwhelming when they put so many words. So It says 6 out of 15 took French, so we need that information. 6 out of 15 took French. 11 out of 15 took math. 14 out of 15 took French or math. And you're trying to find out how many took French and math. So before we start plugging everything in, I'm just going to kind of off to the side write what we figured out. So 6 over 15 is for French. So French, we're going to do 6 over 15. And then just math was 11 over 15. So just math, 11 over 15. And then they give us French or math. So that or is important. So French or math, and they tell us 14 out of the 15. And we basically are trying to find French and math. So that's what we're looking for. So if we plug this into our formula, so our formula will be probability of French or math is equal to probability of French, so always the first one, plus probability of math, the second one, minus the probability of French and math. So it's the same setup every time. You have or, then you have the first one event, the second event, minus the and. So or, we had a number, 14 over 15, so we can plug that in. So a little bit different because they're giving us the answer this time. And then we have French is 6 over 15. Math was 11 over 15. Minus the and. The and is what we didn't know, so I'm going to call that x. So you can clean this up a little bit so we can put these two together. So you have 14 over 15 equals 17 over 15 minus x. And then we can go ahead and subtract that 17/15 to both sides. So minus 17 over 15 minus 17 over 15. So you are going to end up with a negative. That's okay because you have a negative x. So minus 3 over 15 equals negative x. So then we know x is equal to 3/15, which we can reduce to 1/5. So 3 out of the 15 took French and math. Please don't try to work with combinations of these numbers to make this happen. You need to plug it into the formula or it won't work.